Well, although my implementation for source drain epitaxy or other physical mechanisms are not perfect, but I'm just keeping uh, uh, this fabrication procedure. So let's just start the entire procedure, and during it is learning, let me just um, show you the intermediate result for this sustain metal part. So maybe you remember that in the last video we have introduced a certain shape of source drain epitaxial structure. So let's get started from that one. Okay, so this is the case of our previous constellation. Uh, Now we have made a certain CMP procedure, and after that, here we have uh, source drain epi for N MOSFET and P MOSFET. So I have to say one caution, although in this emulation, so both of NMOS part and PMOS part were generated at once. However, in reality, it's not. So in the previous video, I used the term like a silicon germanium. However, for this one, this is a silicon with a carbon, and this one is a silicon germanium, and their shapes are different. Uh, However, I will just keep this same shape and uh, common terminology source drain for my own uh, purpose. And after that, now we add ILD 0. So that is just deposited at first. And of course, at the initial time, there is no such a hole, but that is a pattern. So now, as you can see, source and drain part are patterned. After that, we add linometal, linomaterial, and tungsten is filled. Now you can see certain shape shown here that is corresponding to low-K material like silicon nitride, and that is corresponding to the gate spacer. This is a dummy gate, and this is a gate spacer. Uh, Actually, in this emulation, I introduced just a polygate, no hard mask for it's a can say hard mask for dummy gate. Actually, dummy hard mask is placed on top of um, a polysilicon dummy gate, but that is not considered. So that introduces some problems in its shape. But well, anyway, in this initial trial, I just keep this one. So now, as you can see, this part is now filled with tungsten, so that will be used for source and drain. Later we will connect it to the other one. Okay, so that was the part for generating M0 part, and let's just have a look at this part. Now source drain.cgns is saved. After that, I guess that, where are we now? Now we are doing M0.cgns, the one we are currently looking at. And after that, we will just to make dummy gate removal and also high K and gate metal will be deposited and also CMP is done. So it's just to wait for this M0.cgns and gate.cgns are ready. Okay, so now we are at the final stage of this emulation. Mm, yes, so it takes about 5 or 6 minutes to finish entire um, procedure, and I think that one of the most time-consuming part is the one for this source drain part, because we have to introduce wide bandwidth to mimic the shape of silicon germanium architecture part. Okay, I said now it's done. Okay, gate.cgns. Why don't you just now load gate.ggns file and let's just visualize. Okay, okay. So now you can see that this is corresponding to the gate method. Why don't you just make a comparison between these two? One is the one before we introduce the metal process. So yes, mm, mm, just a link camera and there the same. Okay, it takes some time. Well, previously this yellow one, uh, this yellow one is corresponding to the dummy gate, and now this is pet, this is the etched away. So if we go to here, then without yes, now here we have gate. This is corresponding to the gate metal, and this is high K dielectric. So first we remove this polygate, polydummy gate. After that, we deposit using ALD, high K, and also gate is filled. Of course, this procedure is done with the CMP. So now we have this pattern. Of course, here we don't have any connection to uh, the rear contact. And yes, this is the rear gate, and they are not used. And whether that is used or not, that is determined by the back end of the line. So I will try to keep this kind of exercise later on. Oh, well, anyway, I guess that this is the end of front end of a line emulation, and now we have to go to the next part. We have to make a metal interconnect or something like that. Well, I guess that it will be a little bit difficult for me to follow the entire procedure, but I will try to keep this pace to finish this exercise series. Mm, After that, the physical effect will be improved. Also, more detailed and more well-matched parameters for the structure will be generated. Eventually, I wanted to make a comparison between my emulation result and the fully available open source PDK ASAP7 uh, that is quite famous in this field. Uh, well, actually, the size of my transistors are not perfectly matched to that one, but anyway, I will try to match it as much as possible and also try to make some electrical characteristics from this simulation. Okay, I will come back with more results and thank you for your attention. Bye.